I'm Subramanian, as a Senior Engineering Manager for ECAT team, working at Seagate Technology Group.
Shashi, working as a hardware engineer in Seagate Technologies for One Store Solution Group. So the latest project that we were working on was a 5U chassis, which had multiple boards interconnecting with each other with mid-plane and cables. And it was really a great challenge to understand what kind of DC drop it will have and the system challenges that we are going to face. So Cadence really helped us with its Allegro schematic capture tool and the Sigrity Power DC tool, which was really helpful for us.
Due to dense and complexity of the boards, we would like to measure the IR drop as well as the plane current and VR current density. And we used a Power DC tool to run the simulation because we suspected there might be a IR drop due to the cables which connected to interconnect to the multiple PCBs. So we ran the tool and measured the IR drop at system level. So we ran the first cut of simulation and observed the results, and based on the results we have modified the copper thickness from half ounce to 1 ounce and added the additional plane layers. Then we observed, we ran multiple iterations on the simulations. Then we observed there are good results improved. Then based on the 3D animation view, we observed the current flow direction. According to the current flow direction, we added the multiple VRs and decreased the VR current density issues. So this Sigrity tool really helpful on 3D animation.
So the results that we got from the Sigrity tool were really encouraging for us, because right in the beginning of the project we got the results with which we could understand that what kind of modifications that we need to do in our layout, in our board, and to the power delivery system. So that was really helpful, and another thing was that Allegro and Sigrity are now together, so we didn't have to convert it to the SPD files, and it was really helpful. Other thing was that the thermal performance also we could get from the same tool, Sigrity tool, that we can enter the airflow and those details, and we can get the temperature profile of the planes and the current density, which will vary with respect to temperature.
So to cut the first order problems, we ECAT team ran the simulations, and according to the results we have modified the plane current, plane shapes and VRs, and modified the layout, and before sending the file to the cross-functional teams for review, we ourselves did the first check and sent. So this helps the ECAT team to deliver a quality design.
So if you would ask me, it would be very good to engage initially itself with Sigrity tool, because the density of cards are increasing, the cost is coming down, everybody is asking, there is a pressure to bring down the cost. So which means we need to reduce the number of layers, we need to come down on the planes, we need to come down on everything. So with that, if we engage initially itself with the Sigrity, we will be able to analyze what is the optimum number of layers that we need to. That is definitely a cost advantage for us. And if we engage initially itself, the Sigrity tool can help us in running multiple iterations, and our power engineers and the design engineers can focus on other things like looking at the exact design, from design and hardware point of view, instead of seeing from the current density and VR density kind of.